Let us continue thermodynamic sums. Let us continue the thermodynamic sum. Let us take the sum. The heat of combustion. The heat of combustion. The heat of combustion of acetylene is 312 kilocalories. Is 312 kilocalories. Sir, the heat of combustion of acetylene is given. Okay. So how to write the equation for this we will see. So here combustion of acetylene, that means acetylene combining with the oxygen, carbon combining with oxygen to give carbon dioxide, hydrogen combining to give water. Now we have to balance the equation by keeping acetylene as 1 mole. So here 2 carbon dioxide, oxygen 2 into 2 4, here 1 5, therefore 5 by 2. Now delta H. Delta H means in the heat of combustion of acetylene we can say that is 312 kilocalories we can say. Here combustion in the sense burning in the sense energy will be liberated, therefore it is exothermic process, so that we are saying minus. Then if heat of formation of CO2 and H2O or 94.38 and 68.38 kilocalories respectively. Here what they are saying in this one in the sense heat of formation of carbon dioxide. Formation of carbon dioxide in the sense CO2 is the product, left side is the constituent elements, that is a graphite solid and oxygen. For this is called heat of formation of CO2. What is the value given in the sense 94.38 kilocalories given. Now it is also called combustion of graphite. Combustion of graphite in the sense exothermic, therefore we have to say write negative sign. Next, heat of formation of water. Heat of formation of water in the sense water is the product. Water is the product. Therefore, constituent elements we will write in the left side. We will write constituent element is hydrogen gas and oxygen gas. For this is heat of formation of water. How much given in the sense value is 68.38 kilocalories. It is also called combustion of hydrogen. Combustion of hydrogen in the sense exothermic, that is negative sign we have to give. Okay. Calculate Cc bond energy. Now what they are asking in the sense calculate Cc bond energy. Calculate Cc bond energy they are asking. So what is the meaning of this one that we will see? Calculate Cc bond energy. This meaning is what in the sense gaseous carbon we have to take and another gaseous carbon we have to take. Between them triple bond should be formed. Triple bond should be formed in gaseous state. While what is the amount of energy liberated, that is called bond energy of Cc triple bond. Bond energy of Cc triple bond, we can say that we have to find it. Otherwise, bond dissociation energy means reverse you take. Bond dissociation energy in the sense reverse you have to take. Okay. Next, given that heat of atomization, given that heat of atomization, given that heat of atomization of carbon and hydrogen, are 150 and 51.5 kilocalories, 51.5 kilocalories respectively. Now, here what they are saying means heat of atomization of carbon. Heat of atomization of carbon in the sense we have to take carbon. Available is graphite. Graphite we are taking. Why? Because they have not mentioned which carbon they have not mentioned. That's why we have to convert this into carbon gas, for which what is a heat is involved, that is called atomization. This is a, we can say, endothermic process we can say. Next, heat of atomization of hydrogen, for which we can write equation of H2 gas gives H gas. For this delta H is how much in the sense 51.5 kilocalories. Okay. This is also what in the sense dissociation, therefore endothermic we can say. Then and CH bond energy. and CH bond energy. CH bond energy is CH bond energy is 93.64 kilocalories. 93.64 kilocalories. What is the meaning of this one? We'll see. CH bond energy is given. CH bond energy in the sense take carbon in gaseous state and hydrogen in gaseous state and make a bond CH bond. For this, what is the heat involved? That is called 93.64 kilocalorie. Okay. Here bond is produced. Bond is produced in the sense exothermic. Bond is breaking in the sense endothermic. Bond is breaking in the sense endothermic. Like this we have to take. Sir. Now we want a CC triple bond energy. CC triple bond energy we want. Sir, what is the given data? Means these are the given data. Okay. In the first equation, acetylene is given. Okay. In the acetylene, what is the structural formula for acetylene? That we will see. Acetylene in the sense two carbon atoms present and two hydrogen atoms. Let us give one hydrogen atom to each carbon. Hydrogen can make single bond. Carbon can make four bonds. One bond is there already. Therefore, remaining three bonds will give. So, in acetylene, carbon-carbon triple bond is there. That's what we have to find it. We want to find bond energy of CC triple bond. So, in acetylene, we want. So, we want to find bond energy of CC triple bond. Therefore, we will take acetylene. Sir, we will take acetylene, we said. Okay. So, we will take the first equation as it is. So, first equation, let us take as it is, we will take. Okay. So, first equation is what in the sense? Acetylene plus 5 by 2 O2 gives 2CO2 plus H2O. For this, delta H is how much in the sense? Minus 312 kilocalorie. Okay. First equation we have written. In this equation, carbon dioxide is there. That carbon dioxide we don't want, so we want to cancel this carbon dioxide. Okay. Now, carbon dioxide is available in the second equation. We want to cancel this carbon dioxide. Therefore, let us reverse this second equation. Let us reverse this second equation. Okay. So, let us reverse this second equation. So, what we will get in the sense, carbon dioxide gas gives carbon graphite solid plus O2 gas delta H will see. Here for this delta H is how much in the sense plus 94.38 kilocalories. Okay, because we have reversed. Here two carbon dioxide is there in the first equation. Here one carbon dioxide is there. So we want two carbon dioxide. So let us multiply this by 2. So this equation we are multiplying by 2. So this is 2. Here also 2. This delta H also we have to multiply by 2. Delta H also we have to multiply by 2. Okay. So delta H also we are multiplying by 2 side. Next, here one water molecule is there. That water molecule we don't want. So we want to cancel this water molecule. So what shall we do? In the sense, let us take this equation. Let us take this third equation. In the third equation, water molecule is there. Now we want to cancel. So we will bring water molecule left side. So let us reverse this equation. Let us reverse this equation. Okay. Now we are reversing that third equation. So H2O liquid gives H2 gas and half O2 gas. Half O2 gas. Delta H we will see. Delta H is becoming plus 68.38 kilocalories. Why becoming plus? In the sense we have reversed the equation, therefore becoming plus we said. Okay. Now this H2O get cancelled. Said. Next we can say here graphite is there. If we make the graphite as carbon gas, then carbon atom in gaseous state, then finding bond energy case will be easy. Binding bond energy case, bond energy of CC triple bond given. Bond energy in the sense everything should be in gaseous state. Therefore, if you make this graphite carbon solid as gaseous carbon, then it will be better. Therefore, we want to cancel this graphite solid. We want to place in this place carbon gas. So, which equation let us take? In the sense, we will take the equation number 4. Equation number 4 we will take 150 kilocalories given. That equation number 4 we will take. So, equation number 4 says graphite solid gives, it is solid carbon. Solid carbon is converting into gaseous carbon. For this delta H is given 150 kilocalories. Okay, 150 kilocalories. So graphite solid converting into carbon gas for that delta H is how much means 150 kilocalories we said. Okay. Here graphite is given two times. Here graphite is present two times, but here one time. So let us make graphite two times, for which let us multiply this equation by 2. Okay, we are multiplying this equation by 2. So graphite two times, gaseous carbon two times. This delta H also multiplied by 2. Then here hydrogen molecules present. Instead of molecules, if hydrogen atoms in gaseous state present means we can find a bond energy easily. Bond energy in the sense of gaseous atoms should be there. Gaseous atoms should be there. So we will make this hydrogen molecule as a gaseous hydrogen atoms, for which let us take this fifth equation. Let us take fifth equation we are taking. Okay, that fifth equation is what means of H2 gas. Of H2 gas gives a hydrogen atom in gaseous state. Delta H for this, delta H for this is given how much in the sense 51.5 kilocalories given. Okay, here one H2 is there, but here half H2 is there, so we will multiply this equation by 2. Let us multiply this equation by 2. So if you multiply this equation by 2, this half get cancelled, then this becomes 2 hydrogen atoms. This you multiply by 2. Okay, so now let us go for a, let us let us see the overall reaction what we will get, that we will see. Let us go for overall reaction. What are the common terms? That is cancelling also we will cancel. Carbon dioxide let us cancel, water let us cancel, graphite is cancelling, then hydrogen is cancelling. Okay, then oxygen will see here 5 by 2 O2, here 2 O2 of O2, therefore 5 by 2 O2. Okay, O2 also cancel. Then what is the remaining? We will see in the left side what is there means acetylene is there. Acetylene in which state means gaseous state present set. This acetylene we will write in the structural formula. We will write structural formula in the sense what is that means two hydrogen atoms and two carbon atoms. Then hydrogen makes single bond. We know hydrogen makes single bond. Carbon is making totally four bonds. Therefore, we have given triple bond. Acetylene physical state is what in the sense gas. Then right side what is there means carbon atoms in gaseous state present and hydrogen atoms in gaseous state present. Hydrogen atoms in gaseous state present. For this equation delta H we know by adding all. By adding all these we can get a delta H. By adding all these delta H values we can get delta H for this equation. Okay. Now in this equation, what is there means here acetylene is there, gaseous acetylene is there. This gaseous acetylene, this CH bond you break it, break this CH bond, you will get hydrogen atoms in gaseous state. Break this CH bond and break this CH bond, you will get gaseous hydrogen atoms. Break this CC triple bond, you will get gaseous carbon atoms. So if you break the bonds, you will get gaseous atoms, corresponding atoms you will get. Therefore, to break the bond, what we have to do? We have to supply energy. That is endothermic. Okay. Therefore, delta H of this reaction, delta H of this reaction is equal to breaking this CH bond, breaking this CH bond. Okay. That is how many times means two times. Then breaking CC triple bond, breaking CC triple bond. Okay. Breaking CC triple bond in the sense gaseous carbon atoms you will get, and breaking CH bond in the sense gaseous hydrogen atoms you will get. On breaking CH bonds, we will get gaseous hydrogen atoms. On breaking CC triple bond, we will get gaseous carbon atoms. Okay. Now we know delta H value. Then CH bond energy we know. CH bond energy how much given in the sense 93.64 kilocalories given, that we will substitute 93.64 kilocalories we are substituting. From this what we can calculate in the sense bond energy of CC triple bond we can calculate. Therefore bond dissociation energy of CC triple bond, bond dissociation energy of CC triple bond we can calculate from this because we know the delta H value. So bond dissociation energy of CC triple bond is how much in the sense 160.86 kilocalories. 160.86 kilocalories. Okay. So this delta H we know by adding this. By adding all these values, we can get this delta H value. Using this delta H value, we can find a CC triple bond bond energy. We can find it. Okay. So we got a CC triple bond energy. Let us go for next sum. Using the data, all the values in kilocalories per mole at 25 degrees Celsius given below, calculate bond energy of CC bond and CH bonds. Okay. So now calculate bond energy, of CC single bond and CH bonds. CH bonds. What are the given data? Given data is a carbon solid converting into carbon gas. Delta H is equal to 172 kilocalories per mole. Next equation is H2 gas gives 2 times hydrogen atoms in gaseous state. Delta H value is 104 kilocalories per mole. Next equation, H2 plus of O2 gives H2O liquid. For that, delta H is equal to minus 68. Minus 68. Then carbon solid plus O2 gives CO2. Delta H value minus 94 kilocalories. Then heat of combustion of C2H6. Heat of combustion of C2H6 given minus 372 kilocalories. Then heat of combustion of C3H8. Heat of combustion of C3H8, that is a minus 530. Okay, these are the given data. Using the given data, we have to calculate respective thing at 25 degrees Celsius. At 25 degrees Celsius, we have to find it. Okay. Now, heat of combustion of ethane. How to write equation for this? That we will write. Ethane structural formula we will write. Ethane contains 2 carbon atoms. The 2 carbon atoms we will write. Ethane contains 6 hydrogen atoms. Let us give 3 hydrogen atoms to each carbon. We are giving 3 hydrogen atoms to each carbon. Then carbon is having 1 electron. It can form always single bond. Carbon can make single bond always. Carbon valence is 4. Therefore, it can make 4 bonds. Already it is having 3 bonds. So, another bond. Okay. Ethane. It is undergoing combustion with oxygen. So, what it gives in the sense? Carbon gives carbon dioxide. Hydrogen gives water. Let us balance the equation by keeping it this as 1 mole. So, ethane as 1 mole. So, 2 carbons. Okay. Hydrogen 6. Therefore, 3. Oxygen 2 2s are 4. Here 3. 7. Therefore, 7 by 2. Okay. Next, C3H8. C3H8 contains 3 carbon atoms. We will write 3 carbon atoms like this. And 8 hydrogen atoms are there. Let us give 3 hydrogen atoms to terminal carbons. Terminal carbons, 3 hydrogen atoms. Center carbon, 2 hydrogen atoms we will give. Therefore, totally 8 hydrogen atoms. Now, we will give the bond. Hydrogen makes single bond. Hydrogen makes single bond. Then carbon can make totally 4 bonds. Here 3 bonds are there, 1 bond. Here 3 bonds are there, 1 bond. So totally 3 bonds. Propane. It is reacting with the oxygen gas. Carbon gives carbon dioxide gas. Hydrogen gives water. Hydrogen gives water. Okay, let us balance by keeping this as 1 mole. So 3 carbons. Okay, 8 hydrogens. Therefore 4 H2O. Oxygen 3 2s are 6. Here 4. Totally 10. Therefore 5 O2. Okay, for this delta H is given minus 530. Okay. So these are the equations given. Using these equations, what we have to find in the sense, CC single bond we have to find and CH single bond we have to find. CH single bond and CC single bond we have to find it. Sir, okay. So how to find this, that we will see. Now, what are the given data in the sense? These are the given data. First, we will take a suppose we are taking ethane. Okay, we want CC single bond in the sense in ethane CC single bond is present. Okay, so let us take this equation. This first equation we will take as it is. Okay, we are taking a first equation. So in first equation, ethane plus oxygen gives CO2 plus water. Carbon will write 2 times, hydrogen will write 3 times, and oxygen is 2 2s are 4, here 3, 7 by 2 will write. So for this we know delta H. Delta H is how much in the sense for ethane minus 372. Minus 372. Next, in order to cancel this carbon dioxide, we will take another equation. What is that equation in the sense? we'll take, this is one equation over. In order to cancel carbon dioxide, we'll take second equation, we'll take. So we are taking second equation, that we will reverse. So carbon dioxide gas gives graphite plus oxygen. For that delta H value, we'll see delta H value becomes plus. Here we want 2 carbon dioxide, therefore we will multiply this equation by 2. Why we want 2 carbon dioxide means here 2 carbon dioxide is there, so we will multiply this equation by 2. Okay, so we are multiplying the equation by 2, this also multiplied by 2. Okay, sorry. Next, next case, next we will see here water is there. This water we want to cancel. Why we want to cancel this water? In the sense we are finding Cc single bond energy. Cc single bond energy we want, in the sense we want Cc single bond energy. That means Cc single bond you write in gaseous state. You break this bond by supplying energy. Then you will get what? Carbon atoms in gaseous state. This is the equation we want. For this, what is the energy involved? That is called bond energy of Cc bond. We want this. So remaining things and all we have to cancel it. How to get this? That we have to see. And another one we want to find CH bond energy. CH bond energy, in the sense this bond has to be broken by supplying energy. Then we will get gaseous carbon and hydrogen atoms in gaseous state. For this, what is the delta H? These two we want to calculate. So what we have to, how to make the equation? That means using the given data, we have to get this equation. Getting this equation, in the sense right side gaseous carbon atoms should be there, left side carbon carbon single bond should be there. Otherwise, reverse of this equation also okay. It is left side means it is right side. Anyhow okay. Because this is called dissociation, opposite is called formation. That's all. Okay. Similarly, we want this. So, given data, you make such that we have to get so and so equation. Okay, like this we have to do it. Sorry. Now, therefore, let us cancel this water. How to cancel this water? We'll see. For cancelling this water, let us take this third equation. Let us take third equation. Let us reverse and take. Okay, let us reverse the third equation. Therefore, H2O liquid, H2O liquid gives H2 gas plus of O2 gas, of O2 gas. For this delta H is given how much? In the sense minus 68, make it as plus. Why? Because we have reversed. Here one water molecule is there, but we want 3 water molecules. Therefore, multiply this equation by 3. Okay, so 3H2, 3H2, 3 by 2 O2. This also you multiply by 3. Okay, sir, water we cancel. Next, here graphite is there. Carbon graphite is there, but we want carbon atom in gaseous state. So make this graphite to cancel this graphite. Sir, we have the graphite we have to cancel, that is in right side is there. Therefore, take this equation, fourth equation as it is you take. Okay. So fourth equation we are taking as it is. So carbon graphite solid gives carbon gas. For that, what is the energy? In the sense 172 is the energy. 172 energy you take. Okay. Here graphite is there 2 times, but here graphite 1 time is there. So make this as 2 times. Okay, make this as 2 times in order to cancel. So multiply this by 2. Multiply this by 2. Okay. Now you see that you got gaseous carbon atom in right side. We want gaseous carbon atom in right side, that we got. Cc single bond, in the sense ethane is having Cc single bond. Ethane is having Cc single bond. Okay. So now we want to cancel this 3H2. We want to cancel. If we cancel, that means make H2 as gaseous hydrogen atoms. Therefore, for which let us take this fifth equation. Let us take this fifth equation. We will take this fifth equation. We are writing H2 gas. H2 gas gives hydrogen atoms in gaseous state. For this, what is the delta H value given? You see, delta H value how much given? In the sense 104 given. Delta H given 104. Okay. So we have taken delta H value also. We have taken. So next, we will see that sorry. Now we will add up all these equations. Let us add up all these equations. And adding all these equations, what are the things cancelling? Cancel it. Okay. So carbon dioxide will cancel, water cancelling, graphite cancelling, hydrogen, this multiply by 3, then cancel it, multiply by this 3 and cancel it. So we are multiplying by this equation by 3. So this 2 becomes 6, 2 becomes 6, this multiplied by 3. Now 3h2, 3h2 cancels. Then 7 by 2 O2, here 2 O2, here 3 by 2 O2. Okay, therefore 7 by 2 O2 cancels. So what is the remaining in the sense? Here ethane is the remaining. Left side what is there means ethane. Ethane we can write it as ethane structural formula. We know that structural formula we are writing like this. Ethane structural formula we have written. Then gives 2 times carbon atoms in gaseous state plus 6 times hydrogen atoms in gaseous state. Okay. Now, for this equation, we know delta H. For this equation, we know delta H by adding all. By adding all, we got delta H value. We got it. Okay. Now, delta H of this equation, delta H of this equation, we know that is equal to bond energy of CC single bond, then bond energy of CH single bonds. Bond energy of CH single bonds. Okay. Bond energy of CH single bond, bond energy of CH single bond. Okay. Now delta H we know, bond energy of CC single bond we have to find, bond energy of CH single bond also we have to find. Only thing we know delta H. So we brought delta H in terms of bond energy of CC single bond and CH single bond. Sir. Next, in the same manner, let us treat for propane. This for propane we have to go. Okay. So for propane we have to go now. Now we will take this sixth equation. We will take now. Now we are taking this sixth equation. Sixth equation says what in the sense this propane C3H8 plus O2 gives 3 times CO2 plus 4 times H2O, then 5O2. For this delta H is how much in the sense minus 530. Minus 530. Okay. Let us cancel this carbon dioxide by taking this which equation in the sense, let us take this equation. Okay. So carbon dioxide equation. So carbon dioxide gas gives carbon graphite solid, carbon graphite solid plus O2 gas. For this, what is the delta H value? For this delta H value is plus 94. Here 3 times carbon dioxide. So we have to multiply this equation by 3. So multiply this equation by 3. This delta H also 3. So 3 times carbon dioxide we can cancel. 4 times water we want to cancel. 4 times water out to cancel means take this equation. Okay. So we are taking that equation. H2O liquid gives H2 gas plus half O2 gas. For this, what is the delta H value in the sense? Minus 68. Make it as plus 68. Okay. Here 4H2O is there. Therefore, we want to, here 4H2O. So multiply this equation by 4. So this off getting can off, write it as 2. Now off you write it as 2. You multiply delta H also by 4. Now we want to cancel this graphite. That means convert this graphite solid into gaseous carbon atom. For that, write the equation like this. That means graphite solid gives carbon atoms in gaseous state. For this, delta H value is how much in the sense 172. That 172 take. Here 3 times graphite is there. Therefore, multiply this equation by 3. You are multiplying this equation by 3. Delta H also multiply by 3. Then we want to make this gaseous hydrogen molecules into hydrogen atoms. Therefore, you write H2 gas gives hydrogen atoms in gaseous state. For this delta H value, how much given means 104. That 104 you take it. Here 4H2 is there. Therefore, multiply this equation by 4. So you are multiplying this equation by 4. This 2 becomes 8. This 2 becomes 8, we can say. Multiply this also by 4. Now let us add all the equations. What are the common things are there? Cancel. Carbon dioxide cancelling, water cancelling, graphite cancelling, hydrogen 4H2 cancelling, and O2 5O2, 3O2, 2O2 get cancelled. So what is the remaining in the sense here? Propane. Propane we can write it as in structural formula we will write propane. Here CH2 we can write, then CH3 we can write. CH3 we have written, gives how many carbon gases means 3 carbon atoms in gaseous state plus 8 hydrogen atoms, 8 hydrogen atoms in gaseous state. For this reaction we know delta H by adding all. By adding all we can get delta H of this equation. So delta H of this equation is equal to CC single bond 2 times, CC single bond 2 times, okay, CC single bond 2 times, then CH single bonds 8 times, CH single bonds 8 times. We know delta H of this equation, okay. So we know delta H of this equation. For before equation also we know delta H. We know delta H of this equation. This A equation delta H we know, and this B equation delta H we know, okay. Now we will go for A equation. We'll write delta H is equal to CC single bond plus 6 times CH single bond, CH single bond. B equation will write delta H is equal to uh, 2 times CC single bond, this 2 times CC single bond, 2 times CC single bond plus 8 times CH single bond, okay. Now we know delta H of this. For this we know delta H. For this also we know delta H, okay. We know delta H for this. We know delta H for this. Now what we have to find? CC single bond, CH single bond. How to find? Multiply this by 2, then subtract. This CC single bond get cancelled. You can get CH single bond. Then substitute CH single bond here. You will get CC single bond. That's all. So you got you know how to get a CC single bond. How to get that? You know that is 82 kilocalories. You can say, and the CH single bond also you know how to get it, that is 99 kilocalories, okay. So we got how to find CC single bond and CH single bond, how to get, we know it, okay. So that means we got idea, because we got this delta H. We know this delta H value. This delta H value also you know. Then you know how to get CC single bond and CH single bond, you know it, okay. So let us go for next sum. Calculate the resonance energy of N2O. Calculate the resonance energy. Calculate the resonance energy of N2O from the following data. From the following data. What is the data in the sense? One is standard enthalpy of formation of N2O, that is 82 kilojoule per mole. Then bond energy is given. Bond energy N triple bond N triple bond N 946 kilojoule per mole. Then N double bond N 418 kilojoule per mole. O double bond O 498 kilojoule per mole. Then NO 607 kilojoule per mole. Okay. So what is given in the sense? These are the given data. What they are asking means resonance energy. Resonance energy they are asking means, first we will write a resonance. Resonance we will write for N2O. First we will write a resonance for N2O. Then resonance hybrid for N2O. Then what is resonance energy? That we will see. Then how to do this sum we will see. Okay, first we will go for resonance of N2O. How to write a resonance structures. How to write a resonance structures of N2O, that we will see. Okay, resonance structures of N2O. So let me write N2O like this. N2O we have written like this. So in the N2O nitrogen electronic configuration, we'll write a nitrogen atomic number is 7. Therefore electronic configuration is what means helium 2s2 2s2 2p3. Helium 2s2 2p3. It is the configuration of nitrogen. So nitrogen electronic configuration we have given. Okay. Next, I will write another nitrogen atom. I will take another nitrogen atom, that is helium 2s2, helium 2s2, then 2p3, helium 2s2 2p3. It is another nitrogen atom. Then I will take oxygen atom. Oxygen atom atomic number is how much in the sense 8. That electronic configuration is helium 2s2, then 2p4. 2p4 wantedly I am writing like this. That means disobeying Hund's rule. Okay, the oxygen electronic configuration, oxygen atomic number is 8. Electronic configuration I am writing 1s2 helium, 2s2, 2p4 I am writing wantedly like this, disobeying Hund's rule. Okay, we disobeyed Hund's rule here. We made vacant orbital here. In the oxygen, we made vacant orbital. Okay, oxygen vacant orbital is there. So how the bonding will be there, we will see. This nitrogen, these two make single bond, here bond, here bond. Okay. Then This nitrogen is making dative bond here, dative bond here. Okay, so now this nitrogen valence shell is having 5 electrons. The 5 electrons I will write 5 electrons. Okay, 5 electrons. This nitrogen valence shell is having 5 electrons. That 5 electrons I will write. This oxygen valence shell is having 6 electrons. 6 electrons we will write. Okay, now we will write bonding. We will write how the bonding will be there, that we will write here. Let us give triple bond. Let us give dative bond. Okay, nitrogen oxygen, what bond means? A dative bond we have written, sir. It is one of the resonance structures. Next we will write this dative bond, we will write it as a normal covalent bond by giving formal charges. Here one lone pair is there. Okay, here 3 lone pairs are there. Now nitrogen is a donor, therefore +1. Oxygen is acceptor, therefore -1. Okay, when you write dative bond as normal covalent bond, you have to give formal charges. Nitrogen positive charge, oxygen negative charge you have to give. Okay, it is one of the resonance structures. Okay, next resonance structure we will see. Okay, next resonance structure we are seeing. This lone pair becomes pi bond. This pi bond becomes a lone pair. Okay, so we will write nitrogen, nitrogen, oxygen. Okay, here 2 lone pairs for this nitrogen, therefore negative charge. Triple bond becomes double bond. Here double bond. Here +1 will be there as it is. This oxygen will have 2 lone pairs. Okay, for this oxygen 2 lone pairs, negative charge vanishes. For this nitrogen, this side double bond, this side double bond, therefore positive charge persists. For this nitrogen, positive charge persists. Okay, it is resonance structure. Okay, so we have written resonance structures of what, in the sense N2O resonance structures we have written. Okay, next from this what we can give, in the sense resonance hybrid. Resonance hybrid we can give. Okay, resonance hybrid in the sense contribution of all these structures, contribution of all these resonance structures, we are getting what, in the sense resonance hybrid we will get. Okay, so resonance hybrid is called actual structure. Resonance structures are what, in the sense they are not actual structures. These are false structure, this is actual structure, true structure. Okay, now here, out of this, which is having highest stability, in the sense resonance hybrid is having highest stability. Resonance structures are having less stability. Resonance structures are having less stability. Among these resonance structures, how the stability will be there? Out of these two resonance structures, how the stability will be there? Stability in the sense here, which is having more stability out of these two? Out of these two, which is having more stability, in the sense oxygen is having negative charge, therefore it is having higher stability when compared to this resonance structure. Therefore resonance structure A is having higher stability, resonance structure B is having lesser stability. Resonance hybrid always have highest stability when compared to resonance structures. Resonance hybrid stability will be always greater than stability of resonance structures. Okay, now we will take energy here. Now energy of resonance hybrid will be here. Energy of resonance hybrid will be here. Okay, energy of A, energy of A will be greater than resonance hybrid. Energy of A will be greater than resonance hybrid. Why? Because the stability is less when compared to resonance hybrid. Okay, so it is a resonance structure. Resonance structure A. Resonance structure A. Resonance structure B is having higher energy when compared to A. Resonance structure B is having higher energy when compared to A. Okay, so resonance structure energy we have given. Now, in this one, out of these two resonance structures, it is most stable resonance structure. Most stable resonance structure, we can say. Most stable resonance structure. Now, energy difference between most stable resonance structure and resonance hybrid is called resonance energy. Is called what, in the sense resonance energy we can say. So energy difference between resonance hybrid and most stable resonance structure is called resonance energy. Okay, now what they're asking in the, now we will go to the sum. In the sum what is given means calculate resonance energy. Okay, resonance energy means this we have to find it, we have to find this. Okay, next standard enthalpy of formation of N2O. Standard enthalpy of formation of N2O is given